Hi everybody, welcome to another session of solving another problem on LeetCode live. We are going to pick the next problem in the top interview 150 list. So far we have solved the first 5 problems up to majority element, and today we are going to solve the next one in the list, which is rotate array. So let's open the problem. So the problem is, given an integer array nums, rotate the array to the right by k steps, where k is non-negative. Okay, so example 1 is 1, 2, 3, 4, 5, 6, 7, k equal to 3. So we are rotating to the right 3 times, which means everything gets pushed on the right side 3 times, and then of course it wraps around. So that's why 5, 6, 7 come on the other side. So yeah, it looks like this. Explain it like that. After first rotation, 7 comes on this side. And then after 2 rotations, 6 and 7, and so on and so forth. If this is the array and k equal to 2, then of course 3 and 99 come on that side, and that is rotation by 2. Constraints, the length of the array is between 1 and 10 raised to 5, 100,000. And the value of each element is any value in the integer range, basically an assigned integer range in most program languages is this. K is between 0 and 10,000. Sorry, 100,000, not 10,000. Wow, okay. So follow-up is try to come up with as many solutions as you can. There are at least 3 different ways to solve this problem. Could you do it in place with O of 1 extra space? Okay. So one straightforward approach, which is not the most efficient, I think, that we can take is we can basically rotate by 1, which can be done in O of n time, and do it k times. Of course, if k is very large, we can always take modulo when k is divided by the size of the array. So we, for example, if you rotate by 10, an array of size 7 in this case, it is the same as rotating by 3. So that way, k is bounded to 0 to n minus 1, basically. And 0 is a special case. We don't have to do anything, and it's the same. So k is kind of between 1 and n minus 1. So in the worst case, such an algorithm would, of course, be n square, O of n square time complexity. So that would be one way of doing it. And we could actually try it out. Let's see if we can try it out. So private void, since I'm doing with more than one approach, I'm going to say rotate 1 by 1. That was a lack of better name. And let's just say int nums and int k. Okay, and so here we are going to say rotate 1 by 1 nums comma k. Okay, like I said, we can actually first make k equal to k modulo nums dot length. So that way, for example, if k is 10 and nums is size 7, k becomes 3. And then we can rotate 1 by 1 as many times as there is k. And I equal to 0, I less than k plus plus I. And let's just say rotate by 1 is another helper. And we can also make it rotate right by 1 as the specific name, but it's okay. There you go. And this approach is pretty easy. Basically, you have to shift every number by 1 and rotate the last one in its first place. So what we will do is we'll say int previous equal to the last element, so nums of nums dot length minus 1, and that's the previous element that we'll put in the current spot, and then we'll run a for loop for int I equal to 0, I less than nums dot length plus plus I, and we say nums of I equal to, actually before we reset nums of I, we have to save it somewhere. So temp equal to nums of I. Before we overwrite nums of I, then nums of I equal to previous, and previous equal to temp. Yep. And that should rotate by 1, I think. Let's just run through it a little bit slowly. So I just want to make sure, because it's the main code in the first approach. So let's just go through this array. If this was nums, then we would say priv equal to nums of nums dot, so priv equal to 7, and then we'll say we'll go through the array once, and we'll say int temp equal to nums of I, so temp will be 1, nums of I equal to 7 because priv was 7, and now priv is equal to 1. Then we'll go to the next index, priv will be equal to 1. So we'll first save nums of I into temp, which is 2. Nums of I equal to, yeah, I think this should work. And here, yeah, we have to say rotate by 1 and oops, sorry. So yeah, that should work. Let's try it out. I often have compile time errors when I don't use an autocomplete IDE, but we'll see. Okay, so looks like that was accepted, at least in the 2 cases we have. I do want to try out the modulus thingy. So let's actually add a test case where what we'll say is shift this by 10. And that should be same as shifting by 3, the result. Let's look it up. 5, 6, 7, yep. And what if it is shift by 0? Let's add a test case for that. And haven't explicitly run through that test case in my head, but I want to see if it works. It will work because the for loop actually won't do anything. This for loop here won't even run. And 0 modulo the length is going to be 0. So I think it should work. At least this approach will. Yep, there you go. Okay. Now, as we discussed, this is not the most efficient approach. It's O of n square in the worst case, because we are rotating by 1 n times in the worst case, or n minus 1 times, and rotate by 1 itself is O of n. So it's like having 2 nested for loops. It's like having this code literally pasted here. So yeah, that's why it becomes O of n square. Let's think of another approach. So if we have this array, let's again take this array as an example. Take it here. And let's say we have to shift by 3. So k is equal to 3. Okay, and that is nums. So one approach, which is kind of a trick approach, but is the most efficient and simple, is that we basically should think of 5, 6, 7 as one whole unit, and 1, 2, 3, 4 as one whole unit instead of 1 by 1. And we kind of want to shift this whole unit on this side, but without using extra memory. We could always use extra memory, save that much, and then kind of shift and do it, right? So that would be an intermediate approach, and even better than that would be somehow doing it in place. Now, one way to think about it is if we reverse the whole array, if we reverse this much, right, and the whole array and make it like, I don't know why I copy pasted that, actually I have to write it again anyway. 7, 6, 5, 4, 3, 2, 1. Then the thing is, the 3 elements that we did want at the beginning are at the beginning just in reverse order. And the 4 elements we wanted behind are already behind but in reverse order. So first we can reverse the whole array, and now we can reverse 2 subarrays. So now we reverse 0 to 2, the 3 elements of that are stored in 0 to 2, and reverse 3 to the rest, which is 6, 3, 4, 5, 6, and then you would get your desired result. So if we do that, then like I said, after you do this reverse, you will have something like 5, 6, 7, 5, 6, 7, 4, 3, 2, 1, and after that you will have 5, 6, 7, 1, 2, 3, 4 once you reverse this. 2, 3, 4. Makes sense? Hopefully that made sense. Basically the idea is that think of it as one entire unit instead of one by one, and then to do it in place you have to do a little bit of a trick of reversing the whole array, so at least you have that many elements from the end in the beginning but in the opposite order. So this becomes O(n) because you are basically just doing 3 reverse operations, and each reverse operation is O(n). So it's O(n) plus O(n) plus O(n), which is obviously O(n) also. So that's the approach. For that we need a helper to reverse subarrays. So let's do that in place. So let's do that. So we say int nums, int start, int end, and this is inclusive. We can even make a comment like that. Reverses the subarray num start to end, inclusive of start and end. Reverse, we know how reverse works is we basically start with 2 pointers, one at start, one at end, and keep swapping elements until start and end cross each other. So it's a while start is less than end. If they are equal to each other also, we don't have to swap. And temp equal to, we always need a temporary variable to swap. So we say nums of start and nums of start equals nums of end, and then nums of end equals temp. And then we do plus plus start minus minus end. Okay, so that's how we reverse a specific subarray inside an array. And now that we have this reverse, we have to write our main function of what's it called, rotate by reversing, and then we say int nums int k. Okay, we have to be a bit careful with the limits, but first we have to reverse the whole array, so let's do that. We will also do the same k equal to k modulo the size as an optimization, k modulo nums dot length, so which means k is now between 0 and nums dot length minus 1, which is good because we are going to use k as an compute some start and end indices soon. The first thing we do, like I said, is reverse the whole array. So we'll say 0 and nums dot length minus 1. So that's going to reverse the whole array. And then we say we reverse nums of 0 comma k minus 1. If k was 3, then we want to reverse 0 to 2 inclusive, and reverse k comma nums dot length minus 1. Just want to, it looks too simple, but I want to kind of run through the same example here. So let's actually take this example down here before I kind of run it, the whole program. I want to manually run it. Yeah, so 1, 2, 3, 4, 5, 6, 7 and k equal to 3. So 3 modulo 10 is going to be, sorry, 7 in this case is going to be 3. So that's still 3. And we say reverse the whole array. Assuming reverse does its job, it will be 7, 6, 5, 4, 3, 2, 1. This one, this step here. And then we say reverse 0 and k minus 1. So 0 to k is 3. So k minus 1 is 2. So 0 to 2. So 5, 6, 7. Again, assuming reverse does its job correctly, it should be 5, 6, 7 in place, reversed. And then we say reverse k comma nums dot length minus 1. So that's reversing 3 to 6, 3, 4, 5, 6 indices, and that is that. Let's try to run it by calling it reverse rotate by reversing, and let's see if it works. Okay, compiler. Oh, I have to pass nums there. Yeah. Okay, it says accepted, and we still have our extra test cases we added there, including the one that has 10 there. Yeah, that's great. Given that we have a more efficient approach, I'm also feeling a bit brave and try to submit it and see what our time complexity or time is compared to all other submissions. Let's check it out. Wow, we are beating 100% of the people. Wow, okay. I did not expect that fast, but that's good to see. Memory is interesting. I never understand why, after such really efficient memory usage, why we only beat 66.9%, but maybe the standard deviation there is very small. Okay, I think that is all for this video. Hopefully that was helpful. See you next time.